Hello, my name is Jeremy DeYoung, and for my task 7.1, I have put together a presentation that's going to discuss some object-oriented principles and some examples of them, as well as some design principles as well. To begin with, I'll talk about inheritance. Inheritance is the idea that allows classes to inherit attributes or methods from other classes, also known as a parent class. This allows classes to maintain the functionality of that parent class with additional complexity being able to be built on top of it, or alter that functionality of the parent class while still maintaining all of its core features. An example of this can be seen in the case study we've been building over the last few weeks. Seen below, we see classes player and item inherit the functionality of GameObject class, outlined by the white-tipped arrow. This avoids the programmer having to implement the GameObject features manually into both classes, which allows for code reusability and the avoidance of code duplication. Continuing on, I will discuss polymorphism. Polymorphism, meaning many forms, is the idea of using a single interface or entity to access classes of many different types, thus giving the ability to fully utilize code and avoid code duplication. This is especially useful in a situation where the programmer has multiple classes that perform similar actions or have similarities, or classes that inherit from each other as discussed previously. This can also be seen in the case study as well. Seen in the URL below, classes player and bag implement what is known as an interface labeled I have inventory. Player and bag are different classes, however, they contain the similarity of both using the inventory class that can now be accessed through the I have inventory interface. This avoids the programmer having to address the player and bag class individually, outlining the advantages of approaching class management polymorphically. The next topic I will discuss is abstraction. Abstraction is the process of hiding complexity and unnecessary details from the user. Abstracted items can be used to add additional complexity to the program without the user having to see or interact with any of the logic and code. This allows the user to create complex, efficient, and of course, readable code. An example of this is again the inventory class in the case study. The inventory class in itself already contains a moderately complex amount of code, which can be instantly implemented by the bag class, allowing for mass code reusability. Continuing on, I'll discuss encapsulation. Similarly to abstraction, encapsulation revolves around the idea that abstracted classes have very defined and strict levels of access to their data and functionality, ensuring fields and methods cannot be modified unless required. Examples of encapsulation can be seen in all object-oriented languages, with the use of keywords such as public and private, signifying where the data can be accessed from or has access to. Furthermore, if a data is to be altered or read within the class, it is good design to use properties that act as references to the data within the class, and the use of getters and setters to outline that accessibility. Before I conclude, I'm just going to touch on some very important OO design concepts that has to be considered when implementing the object-oriented principles as previously discussed. The first one is coupling. Coupling refers to the interconnectedness and collaboration of different program components. The different types of coupling can be described as loose coupling or tight coupling. When a programmer is building an OO program, they must consider how the data will flow within their program and structure these classes accordingly. For example, if a programmer wants to reuse a lot of code, they must go for a loosely coupled program as they depend less on the functionality of other classes within that program. The next I'll touch on is cohesion. Cohesion is more central to the individual class, outlining the clarity of the roles and responsibilities. For example, a class with low cohesion can be difficult to implement, test, and understand. When designing an OO program, it is good to use what is known as a single responsibility rule, seen in the diagram below. Classes with too much responsibility are considered bad design, and it is better to have more but less complex modules. This increases code maintenance and readability. These are just some references to some things I've discussed in this in this presentation. Thank you very much for listening. I will conclude.